Students, welcome to Ali Engineering Academy, where you can learn basic electrical engineering, basic electronic engineering, basic telecommunication engineering and basic power engineering. Students, for today our learning objectives will be source-free RL circuits in deriving equation for RL circuits. They are much similar to source-free RC circuit, but the difference between them and this is just the circuit, the capacitor is replaced by the inductor. So inductor हमारे पास सोर्स फ्री RL सर्किट में इनिशियली इसमें एनर्जी स्टोर होगी in the form of magnetic field. So this energy will be consumed by this resistor, which is connected in parallel or series with the inductor. This resistor can be considered as equivalent resistor of the circuit, and this inductor can be considered as the equivalent inductance of the circuit, and the current through this circuit is I, and the voltage across this inductor is VL, and voltage across this resistance is VR. So for deriving equation for this circuit, so let's consider that I of 0 equals I naught. It means that at time 0 the current in this circuit is I naught, so the energy of the inductors will be equal to 1 over 2 L I naught square. Now applying Kirchoff's voltage law around the loop gives us this equation: VL plus VR equals 0. VL is the voltage across the inductor and VR is the voltage across the resistor. Now substituting the value of L into the VL and VR into the equation gives us L di by dt plus Ri equal 0. Dividing each term by L gives us this equations. To finding the current response of the circuits, so integrating both sides to eliminate the differential terms. So here with us di by dt equals minus 0 to t R divided by L dt. So the current is from I naught to I of t, which I of t can be anything. So this gives log of I, and I naught to it equals minus RT divided by L from 0 to t. So putting the upper limit minus lower limit gives us this equation: log of it minus log of I naught equals minus RT divided by L plus 0. Rearranging the equation gives us this equation: log of I of t divided by I naught equals minus RT divided by L. Taking the power of E produce the I of t I naught E minus t2 over tau. So for eliminating the log term from this circuit and keeping the I of t alone at one side gives us this equation, which can be used to find out the current response of the RL circuits, while the time constant of the RL circuit is equals to L by R. So thus we can find voltage across the resistor as also from that equation VR of any time equals IR from Ohm's law. So putting the values of I into this equation gives us I naught R e to the power minus t over tau. Similarly, we can find the power dissipation of the circuit from this equation: P equals VI. So putting the value of VR into the equation gives us I naught square Re minus 2t over tau. So the energy absorbed by the resistor can be found out through this equation: the energy of the resistor at any time from 0 to t p dt. So the integration of power of all the time is the energy of the dissipated in the resistors. As we know that the power is the rate of doing work, so the energy is equal to the integration of power of all the time. So and power is equals, here I naught square Re the power of minus 2t over tau. So getting out the constant from the integration I naught square Re and taking integration of e to the power minus 2t over tau. So reducing this equation gives us this term to find out the energy of the resistor which is consumed by this resistors. So source free RC, the key to working with the source free RL circuit is to find out the initial current I of 0 equals I naught through the inductor and the time constant of the circuits. With the two items we obtain the response as the inductor current IL of t equals I of t equals I of 0 e to the power minus t over tau. Once we determine the inductor current, other variable inductor voltage, resistor voltage and resistor current and power or the energy can be easily obtained from this variable once we know the I of t. So thank you so much for watching these videos. Subscribe for more and new videos and hit the bell icon to get the notification of new videos.